Analog meters have been used for over 100 years to tell us all sorts of information, from temperature to speed, and from loudness to the current in a wire. So why can't we use this ancient tech to tell the time? Well, that's exactly the plan. Today we're going to turn this analog meter into a watch. Here's a quick sketch of the idea I wanted to make for the watch. I wanted to make a completely round body with multiple scales in the middle. I want to have a separate scale for the hour, day, minutes, seconds, day of the week, and month of the year. And I also want there to be 3 buttons so I can pick which one of these I'm actually pointing at. This way at least I can know as much about the time as I need to. To control the actual movement of the needle, I'll be using a Raspberry Pi Pico microcontroller and a digital to analog converter. Then to power it all I'll just use a generic battery I have that fits. And to charge it, I definitely want USB-C this time. I don't want to have some weird ass cable that I have to hand make. So that's the plan. So let's get started. This project actually started a couple of years ago. I never ended up finishing it, but a few months ago I decided to pick it up again, mostly because I thought I could do it a lot better this time. Normally I only ever make one prototype of any project I've ever made, mostly out of laziness, but with the first revision of this watch, it didn't really work the way I wanted it to. In some cases not even at all. And here it is, or at least what's left of revision 1 that is. One of the ideas I had that didn't work was to have a built-in compass. Because the watch wouldn't be designed to be a full 360, you could really only point north. If you wanted to go east, west, or south, it wouldn't really be possible. And another amazing problem is that these movements are actually basically just magnets with coils on them. And if you've ever put a magnet near a compass, you know that it's not going to point anywhere near where you want it to point. So it would be useless as a compass anyway. But having learned from my mistakes, I could do this a lot better this time around. So let's move on, and I'll show you how I made revision 2. Making the second revision of this watch took a lot of prototypes. Here I have all the original 3D printed cases, and here I have the revision 2 cases. The biggest difference is that in revision 2 I decided to get rid of the lugs, and I actually designed these with the battery in mind this time. Initially for revision 1 I had the dial printed on a bit of paper using a laser printer. So with it you can get an understanding of my idea for how I wanted this to look. But at a certain point I decided to redesign it and ended up printing it using a UV printer my friend had. And I'm quite happy with it because it looks a lot more like a dial actually would, with a better legend, more readable, nicer contrast. The PCB, however, went through the most changes. But before I show you that, let me tell you about today's sponsor. PCBWay! PCBWay offers loads of services like PCB manufacturing, PCB assembly, and CNC machining and 3D printing. With loads of options, all you have to do is go on their website, PCBWay.com, upload your PCB or 3D design files, select all the options you want, press upload, wait for one of their engineers to approve it, and once it's ordered, it'll be manufactured and arrive in just a few days. Thanks again to PCBWay for sponsoring this video. And here are the PCBs I got for today's project. The main changes I made between these two were to remove the compass and make the overall PCB a bit more compact. Now you might notice the difference between these two. This is also actually a PCB. This way, rather than having some flimsy piece of paper, it's made of a nice, solid material, and I think it looks a lot nicer. And PCBWay didn't just make these PCBs for me. If you listen closely to the sponsor spot, I also said they do CNC machining. And if you remember from a previous video, I said that I plan on using it soon. Rather than just having a 3D printed case for this, I decided to go a huge step further forward. I decided to have it milled out of aluminium. This aluminium case is a lot closer to what I imagined for the project. Initially I wanted it to have a brushed texture on the outside, but I think going with what's called a bead blasted surface, where they basically shoot fine particles of ceramic or sand at the surface, makes it look a lot nicer. All I have to do is test fit my parts in here to see if they fit. So I quickly fashioned up one of the PCBs, but just the USB-C connector, to see if I can just slide it in. All I need is a screwdriver somewhere here. There we go. And there we go. PCB fits well. If I grab this cable, I should be able to just as easily. It's nice and solid. Quite like that. Now I should also test fit the actual movement mechanism for this, but as I do that, I'll tell you a bit more about how they work. So what these really are is just a magnet and a coil of wire, kind of like a speaker. But where a speaker gets something to move in and out to make noise, this just moves a needle left or right, depending on which way you put the current. I got these from an old amplifier where it showed how much power was going into a set of speakers, I thought, why not repurpose them for something more interesting, like telling the time. Now, I forgot to actually put the dial in, but I think we might run into a bit of an issue if we do that. The dial's going to fit perfectly fine, I'm not worried about that. And I plan to just glue it in there rather than having any magical mounting holes, except for the screws that hold the movement in. The issue right now we're having is that the dial is pushing the needle up a bit. So we're going to have some spacers underneath these two screw holes to lift it up so that the needle can point flatter. Right, because I don't really have any spacers in the right size, what I did was super glue tiny winds of wire. Basically like poor man's spacers. So we'll see how that fits. Okay, so with that, I'm going to try find a temporary way of gluing in the dial, which I've decided is Tesco's homegrown Pritt stick, which is just basically PVA glue. So hopefully these spacers that I fashioned together are enough. And the fact that that can move freely, you see it bouncing around, it's actually a really good sign. So it fits, and I have a piece of glass here that I got. It's basically pocket watch glass. So let's see if this glass fits over top. I think everything fits. Everything fits. Yes! I'm excited. I'm so happy to finally be getting this thing done. So next step would be to actually populate one of these PCBs. So I guess let's get started. Okay, so I've soldered pretty much everything on to the PCB. All I need to do is solder the USB-C connector, and then I can test if everything works. Okay, so let's go over to my computer and see if we can detect this as a Raspberry Pi Pico. Watch the screen now. Okay, that works. I swapped the memory from revision 1 to revision 2, but you can see that this means that the PCB is actually working perfectly, which is great. It can detect the DAC, it can detect everything. I guess now it's time to take this back apart, put the PCB in there, solder those buttons on, because that's one of the few things I'm missing, add the battery, wire the coil in, do all that sorts of wonderful stuff. Then we'll have a working watch. Okay, so that actually fits in there perfectly fine. I just need to solder the leads from the battery onto the PCB. Okay, now we're going to have to attach tiny wires to the actual bottom of this. And for the wires, I've got these super thin, but still slightly stiff wires. Right, so I've got it part of the way assembled, and the moment I plug the coil in, you can see it's actually gently ticking along if you just look closely. That's what the code was doing, is it was just ticking it along once a second. So it's already working, which is great. Right, so with all the electronics in, the only thing we have left to do is these buttons here. And that's what those wide square pads are on the edges. That's what they're for. So we're gonna have to kind of like carefully maneuver these buttons in and solder them down. You know, the buttons aren't actually programmed to do anything yet, but it's nice they're actually in now, clickable. Progress is progress! So just to test fit, I'm going to test fit it with the old glass. Interestingly, it's a watch with only one moving part, which I'm not even sure there's anything like it. I guess, well, I mean, if you count electrons as moving, there's other moving parts, but in terms of mechanical moving parts, there's only one. That quite nicely still fits on top. It's very exciting. Right, before I get to put the actual glass on the top to finally finish this watch, I think we should work on the strap. Now, my first idea was to do something like this, but I have an idea for a more unique style of leather strap that might suit this watch a bit better. I have some of this really nice black leather and elastic. Don't ask me why. I thought maybe why not try something closer to this. This is made of paper, just as like an example. But basically just have a band of leather separated a bit in the middle with elastic on it. That way it's kind of resizable in a sense. It's a weird idea, but it also saves me a lot of effort of having to do a lot of leather working to get this style of thing going. Let's cut a bit out of the leather and see if it works. See if I can make this. Okay, let's just mark out how much of this we need. That's not even slightly symmetrical, so. Now these elastics can stretch quite far, so shouldn't worry too much about these breaking. I'm gonna have to hold it like this now for a second. Right, so I've thought of an idea of how to mount this to the actual strap. So the solution I thought of was to actually just use magnets. Glue them on both sides, and then I should be able to just like pull it off, put it back on whenever I really want to. I'm going to just do that on the prototype watch first by just kind of flipping it over. Again, using our trusty glue. Next time I'll use a bit less glue because that's kind of spill off to the side. But okay, I think that's dry enough. I'm going to use a different super glue for this because I generally can control this one a bit. Well, what I was about to say is I can control this one a bit nicer, and then it pissed super glue everywhere. Well, that's that wasted. We'll try it on another one of the prototypes, prototype 6. There you go, nice little droplets. Now, I think that should be enough. I guess let's just try taking this off. Okay. I can actually do this as well. Twist it, and it'll stay aligned at different angles. Plan now would be to basically do the same sort of transfer thing we did with this, but instead of putting the magnets from here onto there, put them onto the main watch from that one. There we go. And it's on there pretty solid actually. I guess finish off the code so that these buttons actually work properly. So I guess we'll be back to coding in a minute. Right, so I finished up the code, so I'm just going to show you how I've managed to get these buttons to work. But if I press on the top button once, it should go to the hour of the day, and it's just about 10 o'clock. If I then press it again, it should show me the date, which it's the 19th of May. Oh, and if I want to know what month it is, press that and it goes to M. Then I can just have it show me the seconds, which is just that constantly sweeping seconds mode. Then if I want to know what day of the week it is, do that and it's Tuesday. So I had a bit of an interesting idea to try and justify why this strap looks kind of ass. And I've invented a bit of headcanon for it. That being that this is owned by some time traveler, right? This is the professional device he bought from eBay or something, I don't know. And he made a custom strap for it, and on it he wrote his kind of time traveler to-do list. Things he wants to do, things he wants to visit. So what I'm going to do is I've sketched in with a pencil some kind of to-dos for a time traveler. And if you understand all of them, post it in the comments for extra points. SH Time Traveler Party, don't go. Help find spare DeLorean keys. Try Szechuan sauce, ORS recommends. Lunch with Dr. on Beryllium. Then, once the watch, or the strap at the very least, is on, it's surprisingly stable on there, so I'm quite happy with that. I can hold it upside down so it's not going to fall off. Looks like a proper time traveling device. I think now it's about time to close this up and finish this project off. you've gotten this far in the video, thanks a million for watching. It's a project that I never thought I'd actually finish. It was actually supposed to be finished alongside my orange loop watch and shown off at OpenSauce, which some of you might even have seen if you were there. And if you haven't seen the orange loop video, I recommend you go watch that next. I'm actually really happy with how this watch came out. You can see it. You can see it there on my wrist, and you can see how big it actually is. So it's a lot more useful when you can just take it off and attach it to a bit of metal or something. Can you see it there? It's pretty fun, isn't it? So again, thanks a million for watching. Thank you to PCBWay for sponsoring this video, and I'll see you guys next time.